Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is manipulating a C language string. Before proceeding, make sure that you have already watched these other videos first. There are a few different kinds of strings in C++ programming. The most simple kind of string is just having an array of characters. Because this approach has been around since the days of C programming, we sometimes call this approach using a C string. If your software is taking this approach, then you are responsible for allocating all of the memory that you need to store all the characters. You'd accomplish that the same way that you'd allocate memory for any other kind of array. A C string must always be terminated. That means its data must be followed by a special character called the null character. The null character has a value of 0, and it's written using the escape sequence of / followed by 0. So notice that if we want to store the character data A, B, C, D, E, we actually need to have allocated space for at least 6 characters. The 5 data characters, A, B, C, D, E, plus room to store 1 null character after them. You can call this string length function to measure how many characters are in a particular C string. Notice that although string length depends on the existence of a null character to know when to stop measuring, that null character is not included in the final count. This string length function returns 5, not 6. A C string's literal is written within double quote symbols. The compiler automatically allocates an array for this literal, which happens when your software launches. And the array is automatically populated with that character data, including a terminating null character, even though you don't type that null character inside these double quote symbols. Because this is a literal, you should treat that array as if it exists in some kind of read-only portion of memory. You cannot change it. If you pass the string length function an invalid C string that's missing its terminating null character, then that function would just keep on scanning until it eventually reaches some other stray 0 value, which might even be beyond the allocated buffer or memory that you own. To avoid that from happening, you could force the function to stop its measurement after some certain number of characters, such as your buffer's size. Two C strings can be compared by using ASCII's lexicographical ordering. A return value of 0 means that they are equal. Otherwise, the sign of the return value tells you which input string is ordered first. Normally, uppercase characters are considered to be different and ordered before their lowercase counterparts. But if you want your comparison to ignore that difference, it can do so by treating an uppercase character as if it had been lowercase. The function to do that has a different name depending on if you're using Windows or Linux. As with the string length function, you are able to force this string comparison function to stop its action after a certain number of characters. If you want to order by a locale-specific alphabet instead of by ASCII, then call the strcoll function instead. There are functions for copying characters from a source C string to a destination C string. Those two strings should not overlap each other in memory. That destination must already have enough space allocated for everything that will get copied into it. These copying functions merely overwrite some of the array elements in the destination array. The strcpy function starts that overwriting at array element 0. The strcat function does concatenation by starting that overwriting where the destination used to have its null character. For both string copy and string concatenate, a new null character is also copied immediately following the copied data, so that the destination's result will be a valid, properly terminated C string. Normally, the entire source string is copied, but you could copy only the first few of its characters. Be aware that this strncpy function might neglect to add a new null character to the destination, which is something that all these other functions do for you. The two actions of calling malloc to dynamically allocate memory and calling string copy to copy some characters into that memory can be combined into one single function call called strdup. There's a function for searching for where some pattern exists within some data payload when both the pattern and the data payload are C strings. If the pattern doesn't exist, then this function returns a null pointer. Use strchr instead of strstr if the pattern is only one single character. Normally, the function returns a pointer to the first occurrence of the pattern, but you could also request the last occurrence. This next example doesn't search for a matching pattern, but instead searches for the first occurrence of either a $sign or an underscore or an asterisk. These two functions do the exact same search, but one of them returns a pointer to the result, while the other returns that result's index, or the index of the string's null terminator if the search fails to find anything. The strspn function is the opposite of the strcspn function. It finds the first data character that's not one of those options. This string tokenizer function is intended to be called repeatedly. you pass your input string only the first time, passing a null pointer in all the remaining function calls. Also indicate to the string tokenizer function which characters you consider to be white space. Then each call returns a pointer to the beginning of the next white space separated token. Win32 adds a few more string manipulation functions. These act as mappings, converting each of the array's existing characters into some new value. Of course, its terminating null character is not affected. For example, you can change the case of all characters in the string, or you can set all characters to the same value, or you can reverse the order of the characters. Each string manipulation function has a wide Unicode alternative.